Hello, Algebra 2 students. Today we're going to work on graphing and writing equations of hyperbolas. And our objective is going to be, again, to do just that. So if you think back to yesterday, we're working on graphing ellipses. In this whole section, we're basically just working on graphing conic sections towards the end. And we'll talk about what that means tomorrow, a little bit more in depth, I guess. And yesterday we were graphing and writing equations of ellipses. Now our equations for graphing hyperbolas, these things you see here, are going to be similar but a little bit different today. So there's going to be a lot of things you see that are similar. There's going to be some things that you notice that are the same. So what I want you to do is just pause this video and see if you can recognize some familiar things. There aren't any labels, but we see a lot of familiar variables. And you might have noticed, if you just got done trying to observe what's going on here, you might have noticed that, well, we still have this little point here. We have an A, we have a C, and we have a B again. We have an A, we have a C, and we have a B again. And the nice thing is that this A is still going to stand for our vertices, just like it did when we were working with ellipses. However, this B is not quite related, as it's not going to be like our co-vertices. It doesn't really have a name. It's just a point that, well, happens to make a rectangle here, and we'll talk about that in a little bit. And we use it to find these lines. Now, if you look at these lines, what are those going to be? Little dashed orange lines. And those are asymptotes. Those are asymptotes. If you probably noticed that this hyperbola, it's basically like two parabolas, and that's exactly right. And they're going to have, well, two asymptotes as well. We're going to talk about how to find those. And then, of course, we still have a focus, and that involves our C value. So we're going to have very similar definitions, or I guess ways to graph these, but it's going to be a little bit different. So it's going to be important that you distinguish the two, the differences between a hyperbola and an ellipse. Okay, now the definition of a hyperbola, formally, I don't have a picture here, but I might draw one. Formally, the definition of a hyperbola, it is the set, and actually I will draw a picture, a very rough sketch. So if I have a hyperbola here, and I have, let's say a focus here, and a focus here. Okay, well, if I have, whoops, a focus here. If I have a point P, the definition of a hyperbola is that it is the set of all points P such that, that's what ST means, such that the difference, that's the difference of the distances P and two fixed points, those are called the foci again, are a constant. And I guess I should say the difference of the distances is a constant. So what that means is, well, the focus here and some point P, that distance there, we'll call that D2. And the distance from this other focus, we'll call that D1. Well, D2 minus D1 is always going to be just some constant value. I guess I should write constant because we're using C later. Okay, I'm going to write a couple of these definitions and pause the video to save time. Make sure you get these down and then we'll talk through them. So we have these other definitions. The foci are the fixed points located inside each curve of a hyperbola. If you come look at the graph, these C values here, this C, this negative C, this C, this negative C over on this one, those are your foci. And much like an ellipse, they're aligned with that vertex there. And the vertices, well, they're points that the line through the foci intersects. So if we have this line that goes through these foci, this C and this negative C, well, that same line is also going to be where the vertice line lie, but specifically those vertices are on the hyperbola, whereas the focus is not. And if you kind of remember, this is similar to a parabola where we had that focus and then we had a directrix. You don't see a directrix here, but this focus and if it had a directrix would be equidistant. Okay, now the transverse axis, not uber important that you memorize that, but it's the line that joins the two vertices. So right here, this transverse axis is vertical. Right here, this transverse axis on the left is horizontal. And then lastly, the center is just the midpoint of a hyperbola. And we're working with equations in standard form. So our center in this section is always just going to be at the origin. It's always going to be at the origin here. Okay, so let's get to these definitions, these equations. The standard equation of a hyperbola with a center at the origin. You have two forms. And what I want you to do is pause this video and see what you notice the difference between these two equations are. And you should see that they're very similar to what we were working with ellipses. However, what's going on with the a squared, the b squared? Are they moving? And the answer is kind of. And what's going to happen here is the way that this hyperbola is oriented, it's either going to be horizontal or vertical, and it's determined by which value is positive. If your x value is positive, it's going to be horizontal. If your y value is positive, your y squared over a squared is positive, then it's vertical. So think of it, if it's x squared is positive, well, it's going to be oriented horizontally. If it's y squared is positive, it's going to be oriented vertically. So up here we would have this one would be a vertical, or excuse me, we would say that this one, its transverse axis, I should be specific, so that is going to come into play here, this transverse axis, its transverse axis is horizontal. I kind of misspoke, and I'm going to go back and re-clarify this. Whereas in this one, the transverse axis is vertical. And remember that the transverse axis is what connects those vertices. Okay, so again, the transverse axis is horizontal if your x squared value is positive. Your transverse axis is vertical if your excuse me, if your y squared value is positive. Okay, so your transverse axis is going to be horizontal. If your equation's x squared value is positive, your transverse axis is going to be vertical if your y squared value is positive. So keep that in mind. Now the asymptotes, this is probably the trickier thing to remember. I guess this one kind of makes sense. If x squared is positive, then it should be a horizontal transverse axis. And if it's y squared value is positive, it should be vertical. That kind of makes sense. The asymptotes you're going to kind of have to memorize. It's found by doing plus or minus. If it's a horizontal transverse axis, it's plus or minus b over ax. Notice that those asymptotes, they were neither vertical nor horizontal like we've seen several times before. They're actually just linear equations through the origin. And they're found by taking the ratio of b over a when it's horizontal, and then the inverse of that when it's vertical. So a over b x plus or minus a over bx, because there's two lines. Now our vertice, okay, so the vertice, the transverse axis, that you can kind of find intuitively. If your x squared is positive, you know the transverse axis is positive. Or excuse me, you know the transverse axis is horizontal, which means your vertices should lie on the x or the y axis. And if it's horizontal, the vertices should lie on the x-axis, which means you should have some x value for your point. So it's going to be plus or minus a, and then 0. It's on the x-axis. This one will be, well, if it's on the y-axis, if it's a vertical transverse axis, then your vertice is going to be, well, 0, and then plus or minus a here. And actually, I kind of want to do some color coding. So let's go back, do some color coding here. Now you might be wondering where that C value comes into play, that focus, and we're going to talk about that now. So the focus, if it's some distance C from the center, and I don't want to write this in blank, let's go. The focus is some distance C from the center, and it lies on the transverse axis. I guess I should say foci. The foci lie on transverse axis. and it is C from center. From the center. In our case, it will be the origin. It's C units from the center. And it's going to be related to the following in a similar way to the previous one, but not quite. And in this case, it looks just like the Pythagorean theorem. It's going to be, your focus is going to be related as such. C squared equals A squared plus B squared. So this is exactly, it looks exactly like the Pythagorean theorem. And the difference, you want to keep in mind the difference between this and your ellipse. The difference between this and your ellipse on relating those quantities is that when your ellipse was when we're working with ellipses, it was C squared equals A squared minus B squared. So keep in mind that these two are going to be different. If you have hyperbolas, you're going to have to find their quantities using this formula. Okay? So make sure you have these down. And we're going to move to an example where we actually graph an equation here. So we want to graph 25y squared minus 4x squared equals 100. And then we want to identify the foci, the asymptotes, and the vertices of the hyperbola. Okay, but our first thing is first, what we want to do is we have this equation, but what's the problem with it if we want to graph it? And right now it's not in standard form, so we have to get it to standard form. We have to get basically this to look like a fraction and this to be 1. So, well, to get 100 to be 1, we have to divide everything by 100. Because when you're working with, well, if you're trying to simplify an equation, or I guess reduce an equation, you have to do the same thing on both sides. So this becomes, well, 25y squared over 100 minus 4x squared over 100, and technically 100 over 100. Just simplify those down because, well, 25 over 100, that's going to be y squared over 4, 1/4, minus, well, 4 over 100, that's 1/25, or x squared over 25, and that should equal 1. Now, once this is in standard form, what you want to do is identify your a value, identify your b value, and then see if you can find your c value to plot your focus. Well, our a value, we know that a squared equals 4, which means a is going to be 2, and I tried to pin this down. A is going to be 2. Okay, well, b squared equals 25, which implies that b is 5. And you might be thinking, well, shouldn't it be plus or minus 2? Shouldn't it be plus or minus 5? And you would be right if this was just some random variable that we were solving for, but we have to keep in mind that these values were representing distances, and our distances can only be positive. So what we're going to do is, well, we can plot these points. We know, well, since it's which value is positive, y squared or x squared. And since the y squared value is positive, we know, I'll write that down, since y squared is positive, that implies we have a vertical transverse axis. Which means, well, if my a value is here, where my vertice is also going to lie on a vertical transverse axis, so we're going to have 1, positive 2. That's going to be 1 vertice. This is going to be our other vertice, a distance of 2 from the origin in the negative direction, so 0, negative 2. Okay, now this b value, it's not a covertice like it was in an ellipse. It's just a point that's going to lie on this kind of a fictitious rectangle we're going to make here. So it has a distance from the origin of 5. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And now we want to identify the vertice, foci, asymptotes. Well, our vertice we can already get. Our vertice are going to be just some values that lie on the y-axis such that, well, it's going to be 0 and then plus or minus 2. 0 positive 2, 0 negative 2. So we found that. Our foci we have to find, and that's where we have to use the equation from above. So if you want to scroll up and look at your notes, or I guess if you're writing in your notebook, just look up on the page. We can find the foci by finding some c value. And we know that c squared is going to equal a squared plus b squared. And we just plug in our values here, and that's not too bad. So this means c squared is going to equal Well, a squared is, well, 2 squared is 4, plus b squared is 5, 5 squared is 25. So c squared equals 29, or c is going to be the square root of 29. Well, why do we not just write plus or minus 29? And keep in mind that c is representing that distance. So we know from this, our foci, they're going to have a distance of the square root of 29, which is about 5.4. So we can let's just go ahead and graph those foci, because we're going to be doing that anyways. So we go 1, 2, it's a distance. It's going to line the transverse axis, which again, I guess if I want to draw my transverse axis, just make it more clear, it's vertical. Here's our transverse axis. It's going to line the same line that the transverse axis lies on, and our focus is 5.4, so 1, 2, 3, 4, 5, about there, and then 5.4 in the other direction, 1, 2, 3, 4. 5.4 right about, whoa, let's try that again. 2, 3, 4, 5, yeah, okay. 5.4. About there. No, I'm struggling. There we go. That's our foci. So our foci are also going to be on the y-axis. It's going to be 0 and then plus or minus. And you could either write the square root of 29, or if you wanted to approximate it, 5.4. I would take either of those. Either's fine. Okay. So we have identified the foci, we've identified the vertices. Now we have to find the asymptotes. The asymptotes, do those in orange. Got lots of colors today. The asymptotes you can find, and since it's a vertical transverse axis, this one you're going to kind of have to, it's not super easy to just think through and find it intuitively. You just have to remember that if we have a vertical transverse axis, that our asymptote is going to be given by some linear equation, y equals, and then in this case, it would be plus or minus a over b times x, which means, well, y equals plus or minus, our a value is 2, our b value is 5. That's just going to be 2/5 x, which we can't simplify anymore. Okay, so, well, we have this fictitious rectangle that's made by the vertices and these b values. I guess the coordinates made by the b values, I should say. And that rectangle also, coincidentally, if you start at the origin and go to the corner, it's going to give you your asymptote's slope. So if we go, well, we have a slope of 2/5, that means we go up 1, 2 over 5, 1, 2, 3, 4, 5. So we start at the origin, we go here, and it's going to be the same in the opposite direction. And then negative 2/5, plus or minus 2/5 x. So up to the left 5, 1, 2, 3, 4, 5 over here. So that rectangle kind of helps us draw our asymptote as well. So here's our asymptote. Very poorly drawn asymptote, but that's okay. Both teams are trying very hard. I'm going to hide this because it's getting in my way. So here's our asymptote. Yikes. Could have been better, but that's alright. Alright, and then I'm going to draw green. So then you don't need to make a table of values. Just use those asymptotes to kind of know where this is going to go, and it also kind of aligns with that rectangle too. So it's going to, don't want to use orange, I want to use green here. So just use those asymptotes in this rectangle we've constructed kind of to make our hyperbola here, and that's about it. So it's fairly involved, and there's a lot to remember, so make sure you have those notes down pretty well. And that's how you would draw one. Okay, and now we'll move to our last example here where we want to write the equation of a hyperbola when we have given information. So we want to write an equation of a hyperbola. We want to write an equation of a hyperbola with foci at -4, 0 and +4, 0, and vertices at -3, 0 and +3, 0. And I always like to draw a sketch. What I would encourage you to do is maybe draw a sketch, pause the video, and I want you to find, well, is this parabola going to have a vertical transverse axis, or is it going to have a horizontal transverse axis? So pause the video and find that out. And whether you drew it or whether you kind of just noticed, well, this is going to be on the x-axis, this is going to be on the x-axis, which means I should have a horizontal transverse axis. Either way, you should conclude you're going to have a horizontal transverse axis, which implies if you're going to have a horizontal transverse axis that, well, our x squared value should be positive. So we're going to have x squared over some a squared minus y squared over b squared, and that's just going to equal 1. That's the equation we're shooting for here. And we know that, and I'm going to write that down actually, since the vertice and focus, foci, lie on x-axis, that implies we have a horizontal transverse axis. Alright, so if you want to plot these points, that certainly isn't a bad idea. It's always kind of helpful. In your progress packets, you don't have graphs given, but if you want to sketch, that's always a good idea. So we have vertices at -3 here, no, come on. -3. Just struggling with these pens today. Goodness. There we are. -3. +3. And then we have foci at -4 and +4. Okay, but we need to find our b value. And how can I relate those quantities? And you should remember c squared equals a squared plus b squared for a hyperbola. That's how we relate these three quantities. Well, we know c is going to be 4. We know, and I guess I'll write that. We know c equals 4 because we have the given foci. We know that we have these vertices, so we know that a is going to be 3, which means, well, we're going to have 4 squared equals a squared, which is 3. So 3 squared plus b squared, which means b squared is going to be subtract 3 squared, 4 squared minus 3 squared. b equals the square root of, well, 4 squared is 16. 3 squared is 9. 16 minus 9 is 7. So b equals the square root of 7. Which is about, plug that in, well, I guess it's between the square root of 9 and the square root of 4, so it's a little bit closer to 3, so it's like 2 point something. Plug that in and you get, what do we get? You get about 2.64575. And I'm actually going to write this equation now. We have our values. We know that b is the square root of 7. We don't need this approximation. Also, there should be 2.6. There we are. So we'll just round that 2.6. But really, we want to just keep this b value because when we square it, it's going to be positive. So we know that our equation is going to be x squared over a squared. Well, our a value is 3. 3 squared minus y squared over b squared, which is going to be the square root of 7 squared. And that's going to be equal to 1. Simplify that, we have x squared over 9 minus y squared over 7 equals 1. And that's all we have to do in this problem. We just want to write the equation of the hyperbola with the focus and vertice given. Now, I didn't work through an example where you had a vertical transverse axis, but you're going to have to determine that. If the points were going on the y-axis, then you could conclude it has a transverse axis, so on and so forth. So you're going to kind of have to use your intuition to figure out, well, what's the equation going to look like? Which of these is it going to be? Is it going to have a horizontal transverse axis? Is it going to have a vertical? So on and so forth. And actually, just for the heck of it, I'm going to graph this. Since we have the b value, we know that it's about 2.6. Well, I can go 1, 2, it's about here. I'm going to have a value 1, 2, right about here. And just construct our fictitious rectangle. Try that again, kind of missed the mark on that one. And we're going to have these we're going to have these asymptotes. And if you want to practice finding those asymptotes, you can certainly do that. Just know that it's going to go through this rectangle. So since it's not asking for that, asymptote, we're not going to worry too much about getting that equation. But do know how that's found when you have both a horizontal transverse axis and a vertical transverse axis. Okay, and then, well, my focus or my hyperbola is going to look something like this. Okay, and really what we were looking for here is just that equation. So find your A, find your B, find your C values. Those are all going to be important today, just like they were when we were working with ellipses. Okay, make sure you get this progress packet worked on, and then I hope to see you in the Zoom meeting, everybody. Have a good day, and as always, stay safe out there.